In the last class we had studied about bottom chord member. So here will let us know about the rupture strength. Okay. So how do we calculate this rupture strength? For this rupture strength we have a formula in the code book. So that is in the page number 33, IS 800 is there. So page number 30 in IS 800 page number 33 we have a formula that is TDN equals 0.9 into ANC into FUP by gamma M1 plus beta into AG0 into Fy by gamma M0. Whereas here 0.9 it is known, ANC it is an unknown factor, whereas FUP that is ultimate stress of the plate it is known factor, and whereas gamma M1 it is known factor, that is always it is on a standard 1.25, and plus beta it is unknown factor, again we need to calculate it, and AG0 it is also an unknown factor, we need to calculate it, whereas Fy it is known 1. Fy is 250 always, and the gamma M0 it is always standard, that is 1.10. So coming to this beta, first let us calculate the beta value. Beta value, when we have to calculate this beta value, this formula it is also there on the page number 33. So the beta formula 1.4 minus 0.076 into W by T into Fy by FUP into Bs by LC. This value should not be, and this value should be less than or equal to FUP by gamma M0 divided by Fy by gamma M1. It means it should be greater than 0.7. So here whatever is there, first let us know what is this Bs value. Okay, this Bs, his formula is W plus W1 minus T. Okay, where W is this angle, this length 50 by 50 by 6 is there, no? So length into breadth into thickness, right? This length we take that as a W, and whereas W1, how do we calculate this W1? W1 from SP16 page number 168 is there. So in that page number 168, for particular angle for 50 by 50 by 6 your W1 value will be it will be mentioned. I will show you in the next class how that code book I will show you in the next class. So that is, in case if possible please download it at the home. The W1 value is 28 mm and thickness it is already known, that is 6 mm. So this is 6 mm, 6 mm. So Bs equals W plus W1 minus T, that is W is 50 plus 28 is W1 and the minus T, that is your 6 mm thickness. So you will get your Bs value as 72 mm. So after that they have calculated this FUP into gamma M0, these entire time they have calculated. Okay, so that is FUP into gamma M0 divided by Fy into gamma M1. FUP it is always known, ultimate stress of the plate, that is 410, and the gamma M0 it is always standard 1.10, and the Fy is 250 and the gamma M1 is 1.25. The value is 1.44. So now you need to substitute your entire values over here. So beta is already known, in this all the values you have got it here. W no, beta value you need to calculate here, 1.4 minus 0.076, okay, into W is 50 divided by T is 6 into Fy is 250, FUP is 410 and into Bs and LC. Bs is nothing but this is 72 mm. LC it is nothing but pitch distance. Okay, the center to center, the distance between center of the bolt to another center of the bolt, the distance between the two bolts at the center is known as a pitch distance. So pitch distance, you know the formula, that is, what is that pitch distance formula? That is 2.5 times of D. Okay, so what is that? That is 40 mm. So that is pitch distance, and edge distance, that is 1.5 times of D0. Okay, so 1.5 times of D0, already you have calculated your edge distance over here. So the edge distance is 27 mm, round it off into 30 mm. So that is what you have written here. Okay, so this is edge distance and this is pitch distance. Pitch distance it is also called as LC, that is 40 mm. The same thing we have substituted over here. So that is LC value is 40. When you calculate this, beta value is how much? 0.704. It means, so what does your formula says? This value should be less than of this value. Okay, this value should be less than of this value. It means your beta value is 0.704. It means it is less than 1.44. Okay, hence it is safe. So you can adopt your beta value as 0.704. Okay, so next coming to this, so beta value is known. For this, to substitute your to calculate your rupture strength, that is nothing but your TDN calculate madlike. So you know the value of beta value, you got your beta value. So after this, what you need to calculate for this formula, the formula is 0.9 ANC into FUP by gamma M1 plus beta into AG naught into Fi by gamma M naught. Fi by gamma M naught is known factor. Beta value is known factor. FUP by gamma M1 is known factor. Whereas ANC and AG naught, it is unknown factor. So coming to this ANC, we have a formula here, capital A minus D naught minus T by 2 into T. What is this capital A? D naught, it is known, that is 60 mm is dia of the bolt plus 2 mm it is cover. So that is D naught value is 18 mm. T is, that is nothing but 6 mm thickness. So 6 by 2, and whereas therefore A is 50 and B is 50. Why it is 50 and 50? Because you have selected your angle as 50 by 50 by 6. So this is 50 and this side is 50. It means in case if your angle is like this and this part is 50 and this part is 50, this is your A and this is your B. A into B is there, no? The same way A is 50 and B is also 50. The same way you have taken over here, A is 50 and the B is 50. Substitute your value, 50 minus 18 minus 6 by 2 into 6. So your ANC value is 174 mm square. So coming to this AG naught, so AG naught, it is, the formula is B minus T by 2 into T. So whereas when you substitute, B value is also known and your thickness value is also known. When you calculate that, you will get your AG naught value as 282 mm square. Okay. After that, you will substitute your values. Entire, you know the entire values of over here. 0.9 into ANC value is also known, you have calculated here, and FUP is 410 and gamma M1 is 1.25 plus beta is 0.704 and AG naught you have calculated over here, so that is 282 mm square, and Fi is 250, gamma M naught is 1.10. But for this formula, you need to multiply by 2. Why you need to multiply by 2? In case if it is in a single angle, this formula is enough. Okay. But whereas in case when you are selected in a double angle, and for double angle if you are calculating a rupture strength, then what you need to do? You need to multiply by 2. Okay. So after multiplying 2, so your TDN value will be 192.96 kilonewton. So in the next class, I'll start with block shear design. Okay.